Okay, so after we have finished the, what was it, DHCP. Now another subject we will start, which no real network right now is establishing without it at all. It's the First Hop Redundancy Protocol, FHRP. And to be more precise, the FHRP is not really a protocol. It's a family of protocols that all of them works under the same concept and criteria with some minimal differences between them, but yet in the end all of them behave as an FHRP. But FHRP is not a protocol. Okay, so it has three protocols beneath it and we will talk about them, but first let's talk about the concept. Back in some years ago when I was studying CCNA, the old version of CCNA, routing and switching, actually I was studying them with an instructor which I really like and have studied a lot of courses with it. It was Jeremy Chara from CBT Nuggets. Okay, and it, in a lot of cases he did use some sentence that was stating that if you go 2 you are 1, and if you go 1 you are none. What does that mean, and what did he meant about this at that time is that classically the networks that we have drawn and labbed so far were contained mostly of a switch gathering and binding and connecting some end devices, and in the end there is a router that is serving me from the internet and connecting me to other networks. But my small to medium LAN network, local area network, was mostly contains end devices, a switch, a router, multiple switches and a router, and that's it. So there is a router to connect me, but what does this sentence mean is that if you have one router, never consider yourself that you really do have a router at all, because for one of 1,000 reasons you are threatened at any second of time that your router will go down for any reason. Power shortage, extreme extra heat, maybe extreme heating in the environment, high moisture content that the device cannot endure, or maybe some hardware problem. This occurs a lot for so many devices. Maybe the root processor will go down, maybe the other types of processors will go down, depends on the type of your device. Maybe a problem in the backplane of your chassis. Too much uh, reasons that will occur for your device to go down. Maybe this port that's connected to the switch have some problem go down. Maybe this is a fiber optic port, and in fiber optics you have two parts for connection. The first one is the SFP, as we have stated before, and the fiber optic cable itself. Maybe the SFP will go down for a reason, maybe the other opposite SFP will go down, maybe this cable has been broken or accidentally maybe touched by a technician or whatever. So many things, so many reasons, tens or hundreds of reasons that your device might go down for at any moment, and losing your router meaning you have lost connectivity to other networks, to the internet, to the branches of your company or your bank and other places. So going one means that you are never become proud that you have a router connecting you to the gateway, because at minimum you must have two routers, and just in case you have two main routers, you still consider yourself you have one, because you still have those same threats that I've just mentioned, and you're still threatened that at any time maybe you will lose one of them, okay, of these two that you have installed. But yet still this is much better than none. If I lost one, I have another one. So this is the concept of redundancy. Okay, the concept of redundancy. This is a protocol to maintain redundancy just in case you have provided a redundant router. So my network will be two routers connected to a switch and now this is gateway number 1 and this is gateway number 2. Just in case the gateway number 1 fell down for whatever reason, my all my devices will switch to gateway number 2, and they will continue to work on and function and go to the internet and other networks until my gateway number 1 gets fixed, and after that devices will automatically shift back to gateway number 1, and this will go back to its default state, which is the redundant or the backup gateway or the redundant or backup router or device of my network. So this is the big and only concept of FHRP and the protocols that it's working beneath this family of protocols, all these 3 protocols that we will talk about and differentiate in the upcoming minutes. What's happening? Actually, there's something that surprised me in the new CCNA. In the previous CCNA, you had to configure FHRP or all 3 protocols shown beneath. So you had like minimum 3 labs in the previous CCNA. In the new CCNA, the blueprint states only of describe the function of FHRP. That's it. They describe the purpose of FHRP. That's it. Because I believe we will apply it in the upcoming CCNP, maybe in the Enterprise Core exam. You will study the config and the lab and troubleshooting of FHRP and the CCNP level. So what I will do here, I will explain and discuss everything. For labbing, I will not do labs. It's not required, just in case you want it or you're curious about it. It's either I will record the CCNP course and mention FHRP there, or I will do just an extra video and put it outside the playlist for FHRP and protocol configuration and lab implementation. You can enjoy that and implement it by yourself. But for the CCNP new exam, the CCNA new exam, FHRP is only for discussion and concept and theoretical questions, not for implementation and hands-on labs. So FHRP, what if the gateway went down? There is a backup gateway, a redundant gateway must be there. Yes. How to redirect the request? I will talk about this in 1 minute. How many backups can be there? This depends on the protocols. I will talk about it. What protocols? Just 1 minute, and I will talk about the protocols. How to redirect the request from one to another? What do you mean? What I mean is that in chapter 3 and in chapter 4, whenever you configure an end device, you configure it for IP address, subnet mask, and default gateway there. There is a default gateway always in your end devices. This default gateway is the IP address of the first router that I will conflict with. But in this case here, I have 2 routers, so my default gateway will be, if I wanted to take service from this one, I will take its IP address and copy it in my default gateway. And if I wanted to make from this one, then I will take its IP address and I will copy it to make it my default gateway. But how to automatically switch between default gateways? It's either I assign a second default gateway in Microsoft Windows, and this is applicable. There is such option in Microsoft Windows, but it's not automatic, so this is annoying. But if I did so, okay, if I did assign a redundant, or I'm sorry, a second gateway in my end devices, then what will FHRP do? It will do nothing, because giving 2 default gateways to my end device, to my computer, having 2 default gateways will make my end device requesting internet and services from the first one. Whenever it was down, it will request from the other one. So no need for FHRP, not in the switch, not in the router, not in anywhere at all. No need for that. Okay, FHRP, what it will do is that it will, let's clear the mess, it will do this: a switch of the network combining multiple devices, having a main default gateway, a backup gateway, and thanks to the FHRP, what will happen is that after applying the FHRP protocol on the first and on the second gateway, logically and virtually, there will be a virtual router created by between both of them. They will negotiate together to create a virtual router and assign an IP address to this virtual router that is totally different from the IP address from the two other routers, and then I will give this virtual default gateway and assign it as the default gateway of my end devices. So what will really happen is that I will create this virtual router virtually inside router 1 and router 2, and virtually I will assign dot 1 here and dot 1 in here, and giving dot 1 to these two devices only dot 1, only like one, maybe 10.10.10.1, which is the IP address of the virtual router. I will make it as a default gateway for my end devices. My end devices by default will look for the main router, okay, because dot 1 is in here, and when it goes down virtually dot 1 is also in here, so they will automatically just swap to the other one and they will complete to take the service from the other one. Okay, so this is what FHRP does. Some commands to virtually create a router, and this same router will be virtually created in between the two routers R1 and R2. By default, I will take service from the main router. When it goes down, I will take the service from the stand-up or router, the standby router, sorry. So other terms are main router or master router, depends on the protocol you are using, and the standby router. Okay, I think this one is called the active router, or main or master, depends on the protocol, and the other one is called the standby router. How to make which one of them is a main and which one of them as a standby? This is done and achieved by assigning manually a priority for these two devices, and the one with the higher priority will become the main router, the active router. The other one with the lowest priority, with the lower priority, will be the standby router. Okay, this is another thing to know. The third thing, an important thing to know, is that you have just mentioned a few minutes ago that whenever, after shifting the traffic to the other one, to the standby, and after this main router gets fixed and back again to work, the traffic will automatically go back. This is not done automatically unless you enter a command called preempt, and that is a shortcut, a short for preemption. When enabling preemption in both routers, this will inform both routers that just in case R1 is back to work after it failed before, just shift the traffic back to it and make the things and or the environment looks like the default behavior, just like nothing happened at all. Okay, so this is not done manually or by default. This is done after configuring the preempt command in both the routers. So now you have to create a virtual router in both routers. You have to assign priority in both routers. If you did assign a priority in only one router, make sure that this priority is greater than 100, because 100 is the default priority in both of them, which is by default. Once you enable FHRP, the default priority will be 100. So in case you wanted to configure only one router for to become the active router, just make it 110. That's enough. 101, whatever you like. The other one, leave it as its default state, which is 100, and it will become automatically the standby. Okay, so after virtual router and priority, you have the third thing to configure, which is preempt, and that's it. 3 commands to configure, and that's it. Escape everything and everything. FHRP is now configured, running and working, and that's it. That's all you have to configure on FHRP. Now, what do we need to know also about FHRP is that the 3 flavors of HRP, and why there are 3 flavors of HRP if 3 of them works as the same exact concept of FHRP. Actually, the first protocol of FHRP that was ever introduced to us was introduced by Cisco, and it was called the Hot Standby Redundancy Protocol, known as HSRP. It was working only on Cisco routers. This is a big problem because if you have any other devices in your network that are not Cisco routers, so they will not cooperate in the environment of FHRP or HSRP with the Cisco routers. It was allowing for a maximum of two gateways. One is the main, the other one is the standby, and there is no traffic load balancing between them. It's either you use the main one and the second one will stay standby maybe for 10 years. If the main one, the active router, did not went down for 10 years. Just imagine this perfect scenario. For 10 years your main router is working normally. Then for 10 years you just have an expensive, strong, highly resourced standby routers that is just for being a backup like this for years without doing anything at all. Okay, so this is the problem of HSRP, that it doesn't support load balancing. Can be manipulated in CCNP, and just in case I made a course of CCNP, if you're required so, I will definitely do a lab of load balancing, which is type of manipulation, not a default behavior of HSRP, but we can do it, no worries. Okay, after that, IEEE, which is an open standard organization, had produced VRRP, which is Virtual Router Redundancy Protocol. The redundancy protocol is not clear to you, I believe. Okay, so the IEEE had produced or developed the VRRP. The VRRP supports two gateways, no load balancing, just like HSRP, but it's an open standard. So using VRRP in an environment that contains routers of different vendors, including Cisco, all of them do support VRRP. Cisco routers and other routers, all of them do support VRRP. So this was much more used, I'm sorry, because it's an HSRP but supports other routers. So just even if my environment contains only Cisco routers, I cannot guarantee that in the future I will not have maybe a perfect deal with another company and I will install routers from another company just in case I received a good offer or discount from them. This happens in all of the organizations. Okay, so in the future I might have other routers from other vendors, and at that time changing the configuration of all the network and removing HSRP and installing VRRP will be a problem. So why don't we install VRRP from the beginning, so that when we maybe have increased scalability in the future, it will be no problem. We can just get our network to grow with no problem without changing any protocol. So VRRP got more popular, but Cisco replied with a bomb, which is Gateway Load Balancing Protocol, the GLBP. Again, it only works on Cisco, but now it supports 4 gateways, not 2 gateways. This is very appropriate for very expensive tier 1 networks or very big and old companies that do give, maybe they have like 10 million clients, 20 million clients, 100 million clients. Such companies do whatever they can do and purchase whatever amount of money to be online all the time and never suffer a packet loss, a jitter, what do we call it, a congestion, whatever at all, for any reason, no delay at all. So yes, they will install 4 gateways, 3 gateways, and they will maintain redundancy. They will say whatever a disaster will happen, one of the routers got sank in a storm, the other routers went down for electricity, we'll still have a third and a fourth. The other bomb was load balancing between the 4 of them. You can just imagine, if I have a traffic or a bandwidth of 1000 megabit per second, GLBP will allow me to install 4 routers. All of them may be connected to the same switch or multiple switches no matter. I can do whatever I like in the design of switches, and I will maybe make each one of them carries 25% or quarter the bandwidth or the traffic, 25% of the traffic. In case the first one failed, the other 3, each one of them automatically will carry 33% between them. If the second one failed, automatically both of the third and the fourth will carry 50% of the traffic. The third one failed for whatever disaster is happening, there is a fourth one carrying 100% of the traffic. So I can do 4 gateways and load balance between them. This something wasn't at all mentioned neither in VRRP or HSRP, and VRRP and HSRP never were developed to support such thing. So GLBP came there to not solving problems only, but giving new features that we wouldn't maybe think of or ask, but it was there to do so. Okay, so these are three flavors of, or three subversions of the FHRP family. Actually, I've told you in the past two versions of CCNA 201.120 and 201.125, which are version 2 and version 3 of the CCNA routing and switching, all the three of the FHRP protocols were to be practiced on lab and implemented. So right now it's only by describe the purpose of FHRP. So I will only describe the purpose of FHRP, and I hope when we make a CCNP course, we will do our best. Maybe we'll do like 5 labs of FHRP: standard mode, manipulation, load balancing, connecting together, insert DHCP and HSRP in the same router. This will be a bomb. We will do everything. Okay, so so far this is only the concept and the idea of FHRP. I hope it's really clear to you. Just in case it wasn't, just inform me down below in the comments of the video. I will do my best again to redescribe and show you the how the FHRP works, and also maybe provide you with some extra resources for that. And also subscribing the channel and liking our video will be big favor from you. Okay, so thank you for watching, and I will see you in the upcoming videos. Goodbye.